and welcome to your next video. Today what we're going to do is we're going to take what our log rules were and we're going to use them to solve equations. Solving equations, it's the good old school way of saying I'm going to solve for x. But we need to lay down some rules. Some of the rules that we have here about solving this is that if I'm given two sides of an equation, like I am right here, where I have the same base and the same base of a log on both sides, and I have one log per side, then what's on inside the logs is going to be equal to each other. Again, my rules are, log on each side, only one log on each side, log is in same base. Then I can say that they're equal to each other like that. The other thing that you need to know that they point out to you here is that if I'm looking to solve an equation that looks like this, if I'm looking to solve e to the y is equal to 2, well, how can I possibly find out what that is? Well, they say, well, I can go ahead and take the log of both sides, or in this case, the natural log, because if I take the log of the base that the exponent is in, ln of e to the y is going to be equal to the ln of 2. And what you need to know is, hey, this right here is the key part. Why? Because ln of e to any exponent is going to be that exponent. So y is equal to ln of 2. These are the two things that you need to know in order to be successful in solving log equations. The first couple examples we're going to do are going to concentrate on this rule over here. You ready? Okay. So here we go. It says solve 2 log n of x for 18, round to the nearest hundredth. Alright, so I go ahead and I'm going to rewrite this out here. 2 ln of x is equal to 18. Now before you get too happy about trying to go, well, hey, this 2 can be here. It's going to, oh, watch this. I know what to do. ln of x squared is equal to 18. Now what, coach? Okay, well, what do I do? I don't know. Kind of stuck. So let's back up a little bit and let's say this. Let's go ahead and erase. If I come here and I say, well, what if I divide both sides by 2? Which I can do. Now I have the ln of x is equal to 9. Well, again, I'd be stuck, so what now, coach? Well, let's see. The best that I can do is I can say, well, what base is this? What base is this? Oh yeah, it's base e, so this is the same thing as saying log of base e of x is equal to 9. And I have to remember, what's that phrase? Is that e to the 9 is equal to x. E to the 9 is equal to x. Now I can find this out. Okay, here's something amazing. If I were to go ahead and go back to where I was, right? ln of x squared is equal to 18. And I did the same thing, and I changed it to log base e of x squared is equal to 18. And I go, oh, that just means that e to the 18th is equal to x squared. And then I could go ahead and take the square root of that. The square root of e to the 18th power is equal to x. And it's going to give you the same answer. Psh, mind explosion. Now, I don't have my calculator up and running, and I don't want to waste your time trying to go get it. Okay, but you can go ahead and put e to the 9th in your calculator. typo. This one here says same type of deal. So I have a 7 minus 3 log of 10x is equal to 13. So in these, what I like to do is I want to try and get the log part, this part here, all by itself. Okay? So I'm going to do that. I'm going to subtract 7 from both sides, and I get a negative 3 log of 10x is equal to 6. Divide by a negative 3. I get a log of 10x is equal to a negative 10. Negative 2, not negative 10. Now what? Well, again, there's a couple of different ways to look at this. One of the ways that sticks out to me is I'm thinking, I can do the same deal. This is log, again, what's the base? There's nothing there? 10. So I can say, well, hey, this is 10 to the negative 2 is equal to 10x. 10 to the negative 2 is equal to 10x. Well, what is 10 to the negative 2? 10 to the negative 2 is 1 over 10 squared, which is equal to 10x. And now what? Well, divide both sides by 10. It's 1 over 10 cubed is equal to x. Well, what's 1 over 10 cubed? It's 1 over 1,000. 0.001 is equal to x. Didn't even need a calculator. How cool is that? Now it says nearest hundredth. I think whoever wrote this wasn't right. That's your answer. Let's go to what's next. Think. Alright, so now we get to the ones like the first one, where my goal here is to get logs. I have a lot of logs. In fact, I don't have any numbers by itself. I just got logs galore. Log, 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 log. And look, they're all the same base. So what my goal might be to do is to try and condense one side to where I have one log on each one. So if I keep the log 2 here, base 2 of 5, and I condensed what's happening over here from our last one, this would be log base 2, 10 divided by x minus 4. Now look, do I have one log on each side? Check. Do I have the same base? Check. So what am I going to do? I can get rid of the log parts, and I can say 5 is equal to 10 over x minus 4. 5 over 1. And now I have my proportion that I've been used to and doing forever and ever. So this is equal to 10 times 1 equal to 5 times x minus 4. That's 5x minus the 20. Solve for x. Add 20 to both sides. 30 is equal to 5x. Divide by 5. 6 is equal to x. And now here's the key part. I need to make sure that my answer makes sense. I gotta go back to my original problem. Okay, I need to check my answer. We'll know more why in a second, but I'm going to get you in the habit. We need to check answer. So every time you find an x on solving these log problems where you got a log on both sides, the last step that you need to do is check answer by plug in. So I take my 6 and I plug it in up here. Log base 2 is 6 minus 4. Okay, so what's 6 minus 4? That's 2. So again, when I plug back in, I'm going to scoot this up a little bit. I had log of 5 is equal to log of 10 minus log of my number 6 minus 4. And I can check myself and say, well, that's log of 2. Log of 10 minus log of 2 is equal to log of 10 over 2. I'm checking to see if that works. 10 divided by 2, oh, that is 5. So log of 5 does equal log of 5. So I did. I checked it out. Everything worked. Great. Let's see what's next. Again, I have got logs on both sides. Check. Are they the same base? Check. Oh, look, I don't have to do much of anything. All I have to do is come here and do x squared plus an x is equal to 20. Because the logs are the same base, there's one log on each side, I can set them up. Now I just turn this into a quadratic equation. X squared plus an x minus a 20 is equal to 0. And I want to find my zeros. So x plus 5, x minus 4 is equal to 0. Solve for x, set each one equal to 0. X plus 5 is equal to 0. X minus 4 is equal to 0. X equals negative 5. X equals 4. Again, I need to check in my original problem, does this work? I put negative 5 in there. Okay, so I have log base 5. Negative 5 squared is a positive 25. Oops. Plus an x, which is plus a negative 5. Does that equal log of 20? Base 5? Well, 25 minus 5, yep, that does equal log base 5 of 20 is equal to log base 5 of 20. Check. What about with the 4? Log base 5 of 16 plus 4. Does that equal log base 5 of 20? You betcha. And you might be thinking, Self, why is he making me do all of this extra work? The correct answer is it's not extra work. You got to check your answers. Because I guarantee you there might be a problem on a quiz or a test that's coming up that you're just going to be like, but bam, I'm going to give you both answers and one of them might not work. What? They may not work? Yeah, let's keep going and finding out. Okay. So I have this one here, log of x plus log of x minus 3 equals log of 28. Okay, so I go, okay, I got logs on both sides. Do I have just one log on both sides? No. So I need to do something beforehand. So I need to combine or condense these two here. I just have log. This is x times x minus 3 is equal to log of 28. Hey, now do I have one log? Check. Now do they have the same base? Check. So I can get rid of the logs now and I can just say, well, this is going to be x squared minus a 3x is equal to a 28. Subtract 28 from each side. X squared minus a 3x minus a 28 is equal to 0. And I got going, okay, what two numbers add up to be, multiply to be negative 28, but negative 3, oh, here we go, x, let's see here, minus a 7, x plus a 4 is equal to 0. I start solving here, x is equal to 7, x is equal to negative 4. Great. So I go plugging in. If I start with the 7, log of 7 plus log of 7 minus 3, does that equal log of 28? Well, this is log of 7 plus log of 4, does that equal log of 28? Well, yeah, because I have my rule, right? A condensing rule. I can multiply them. So this is just log of 28 does equal log of 28. No rules were broken. Everything is great. And now I get to something interesting. In fact, so interesting, I'm going to change the color. When I go into negative 4, I have log of negative 4 plus log of negative 4 minus 3 is equal to log of 28. And if you were to work this out, you'd keep going. You'd say, okay, well, this is going to be log of negative 4 plus log of negative 7 equals log of 28. Is that the case? Is that the case? You go, well, yeah, because negative 4 times negative 7, that's positive 28. This is looking great. Log 28. So what is possibly wrong with this? This part here. There is no way that you can go ahead and put in a log of negative 4 and get an answer. No way. So why can't I do that? Well, if you put it in your calculator, and I dare you to, and you get no real number, it says error. Okay, so even though the math looks like it works through here, this is wrong. Why? No negative numbers in logs. None. It's not part of the domain. Okay? None, 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 none. None. Which is why it's important to go back and check your answers. So what does that mean? That means my only good answer is x equals 7. X equals negative 4 does not work, is not an answer that we will want. Okay? Let's do what's next. Okay, it says here, solve this big giant problem of fun. So I'm going to. But I noticed something here. Do I have log on both sides? Yes. But I have an extra 1. So I'm going to go back to that trick that I did for problem number, one of our problems that we did, where I said, hey, this is all in log, right, base 10. So I want to change this into log base 10. I want log base 10 of some number has got to be equal to 1. So 10 to the first power, 10 to the first power is equal to x. Oh, so log base 10 of 10 is equal to 1. So now I can rewrite this here as log of 3x minus 4 is equal to log of 10 plus log of 2x plus a 3. All right, do I have everything in the same log? Yes. Is there just one log on each side? No. Crud. All right, so that means I got to come over here and I got to go, well, this is log of 3x minus a 4, okay? Oh, look, these things, I can combine them somehow, condense them with a plus, multiply. So now this is log of 10 times all that business, which will be 20x plus a 30. Bing. Do I have the same base of logs? Do I have one log on each side? Check and check. So now I can get rid of it and say this is 3x minus a 4 is equal to a 20x plus a 30. Solve. Subtract 20 from each side. Yeah, or let's just do it this way. Add subtract 3x from each side. And so this is 17x. Subtract a 30 from each side, negative 34. That means that x is equal to a negative 2. Yay, I got an answer. But what am I supposed to do? Check it. So when I check this, I get log of 3 times a negative 2 minus a 4 equals 1 plus log of 2 times a negative 2 plus a 3. All right, so this here's a log of negative 6 minus a 4 is equal to 1 plus a log of a negative 4 plus a 3. Do you see what's happening? Oh no. Log of negative 10 is equal to 1 plus a log of a negative 1. Uh-oh. what do we got? Negative answer, negative inside my log. Negative inside my log means this does not work, and there are no real solutions. Okay? Check your answers. I guarantee you -2 would have been an answer choice. Bada bing. All right, last one is how is this used in a real world type of example. It says here's my Richter scale. Okay, the Richter scale of magnitude is given by, so R is equal to all this blah, 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 E plus 1.46, where E is the energy in kilowatt hours released by the earthquake. So an earthquake releases this many kilowatt hours. So what is all of this of energy? That's E. What is the earthquake's magnitude? What are they asking me to find? They're asking me to find R. Oh, so this is just a simple plug in. 0.67 log 0.37 times E 15,500,000 plus 1.46. And if you had a calculator handy, you'd be able to see that the answer is equal to 7.99 on my Richter scale. Part B makes it a little bit more interesting. Part B wants it to go the other way. It says, how many kilowatts of hours of energy, that's my E, would an earthquake have to release in order to have an 8.5 on the Richter scale? Again, there's R. So for part B, I need to be able to sit here and write down 8.5 is equal to 0.67 log of 0.37 E plus a 1.46. Okay, so my first step to go ahead and do is to go ahead and take 8.5 minus 1.46 from each side, and I get 7.04 is equal to 0.67 log 0.37 E. Divide both sides by 0.67, and what I end up getting is 10.507 is equal to log of 0.37 E. And again, what am I doing here? It's a great question. But what I do know is log is in base 10. If I have 10 here, saying 10 to this power is equal to this. So 10 to the 10.507 power is equal to 0.37 of E. So put that in your calculator. 10 raised to the 10.507 power divided by 0.37 is equal to about 8.685 E to the 10th. E10. That's what my calculator says. Well, what does that mean? That means that I would have an 8 now with 10 decimal places moved over. So I take this decimal, move it over 10 times. So I have the 685,000,000,000. Right? Where's my decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I put in my commas, the amount of energy that was released was 86 billion, 850 million kilowatt hours of energy. And theirs was mind-blowing. You want to know what's mind-blowing about this? From 7.9 to 8.5 on the Richter scale, which seems like relatively small, look at the magnitude and difference between the kilowattage hours. It's like 4 times the amount. 5 times the amount. Oh my gosh, 5 times the amount was released. That's huge. Huge. And which makes Richter scales kind of cool. All right, that does it. We'll have some work to do. Sorry about the length. See you guys tomorrow.